This is a quick overview of my first Arduino project, a wireless water meter for an outside stream. In July of 2013, my parents built a stream in their backyard. At the end of the stream is a pit in the ground, covered with rocks, that collects the water and is about 3.5 feet deep. An electric pump at the bottom of the pit takes the water and runs it through pipes back up to the top of the stream, where it flows down a small waterfall to start the process all over again. After it was built, my dad said he was worried about not being able to easily check the water level of the pit at the bottom of the stream, because if it got too low, it could burn out the electric pump. I decided to build a wireless water meter that would let him check the water level of the stream from inside the house about 30 to 40 feet away. Since I am new to programming and electronics, I decided to use the Arduino microcontroller platform for both the inside and outside units, since it is inexpensive and good for beginners. Using a program called fritzing, I created virtual prototypes of the electronics for a unit to stay outside and measure the water depth, and a unit to stay inside and display the measurements from the outside unit. The two units communicate using very inexpensive 2.4 GHz radios. The outside unit uses a PVC pipe with a common anode that runs the entire length, and then 8 bolts that are connected to analog inputs on the Arduino. When it is submerged, water conducts electricity between the anode and the bolts, and a water depth can be read at 8 discrete levels. The outside unit also measures the outside temperature, the outside humidity, and the temperature of the water in the stream. The inside unit uses a cheap car LCD screen connected to the Arduino by a simple RCA plug, and is run by the amazing TV Out library. After creating the virtual prototypes in fritzing, I went straight to soldering the components together and shaping the enclosures, which took a few days in total. After finishing all the hardware, I went to work programming. Programming the outside unit and placing it outside only took about 2 hours, but programming the inside unit took a few days to complete, and then a few days to fully debug. My completed program compiles and runs without bugs and is over 1,000 lines long. Here's the completed external unit by the end of the stream. Here is the completed inside unit while powered off. So you can see that it actually works. Here are both units being tested inside with a bucket of water. The LED on the external unit flashes when current is flowing through the water to measure it. Here's what the main graphical user interface looks like on the internal unit. The water level outside is indicated by a virtual tank with 8 levels that show us either full or empty. There are 2 temperatures next to the tank. The top one is the temperature of the water, while the bottom is the temperature of the outside air. Above the tank is a percentage range. This is the estimated percentage of the tank that is full. Above that is 2 lines of text that let the user know when the device was last updated with new information from the external unit. Finally, at the very top, the arrows point to the 4 buttons above the display that let the user interact with the device. Here are the features of the internal unit. Every 20 minutes, or whatever interval I set it to, the internal unit will automatically fetch an update from the outside unit. If the user wants to manually get a new update, they can do so by pressing a button on the side of the device. If the user wants to see the current date and time, they can press the clock button. For diagnostics information, such as the humidity of the outside unit and the data transmission rate, they can press the diagnostics button, indicated by a stethoscope icon. The internal unit is set to alert the user if anything is wrong by flashing its lights and beeping. It can be set to go off if the water level is too low, it can't make radio contact, or for several other reasons. When an alarm is going off, the user can either press the 2 buttons marked with the letter C at the same time to manually clear the error, Or they can wait, and after a set amount of time, the unit will fetch an update to see if the error has been fixed. Both the inside and outside units run off AC adapters, so now that they are set up, no upkeep is required to keep them running. They have been functioning without issue for a few weeks now, and have proved very useful in keeping an eye on the water level of the outside stream. Thank you for watching this video, and if you would like to see more information about this project, please follow the link below in the description. Or visit my website at joshuatz.com.